0100, exactly half of this address. 0100, then A1. Up to here, you are having the 24 bits. This belongs to OUI. And this one you are having, right? 2B4E6A. This particular portion, it belongs to the device ID. Okay. So how exactly you can find out the OUI? There is basically a simple process is there which you can follow. Simply just follow this simple process. Okay, just open your browser and over there, you simply just type OUI IEEE. Okay. Can you see that? OUI.txt.
Yes.
Just click on it. Can you see all these numbers?
Yes, sir.
Okay, this is in hexadecimal. Hexadecimal format means this dot will be there. Okay, over here. Can you see this hyphen is there? No? This is the hexadecimal. And base 16 representation is just writing everything, the same thing. You can see you are writing it all at once without giving any type of dots. Okay, without giving any type of hyphens. You are simply just writing all the values. This is a base 16 representation. So can you see Realme?
Yes,
Cisco
sir.
Systems. Can you see Nokia?
Yes.
Over
sir.
here, can you see the Dell? If you are having a Dell laptop or anything like that, you will see Huawei company is there. Over here, down Xiaomi, Motorola, Vivo. Vivo is having a couple of UIs. Okay, so some companies, there's Samsung over here. All these companies. Okay, it's a long list. It's a very long list over here. Okay, so all the OUI list is available in this text form. Okay, text document. You can simply just search OUI IEEE. IEEE full form is what? IEEE
Institute of Electrical and Electronics Engineers, I think.
Electronics engineer or engineers?
Engineers.
Are you sure?
Yes, sir.
Huh?
Yes, sir.
Institute of Electrical and Electronics Engineer or engineers?
Engineers.
100% sure, Suman?
Yes, sir.
Sir, engineer, sir.
Engineers, I think.
I'm just giving some pressure from Suman. All of you are like what, jumping into this situation. I'm just testing that whether she is confident or not. At least this much I can do, right?
Yes, sir. Of course.
Yes, sir. Yes, sir.
So okay. This is what you are having, everyone. Simply just take a screenshot of this entire thing. Take a screenshot of this. Taken.
Sir, MAC address is permanent of every devices.
That is correct. Permanent. It's a permanent address. Okay.
Sir, 48-bit address, MAC address,
that is
permanent.
Permanent address. Okay, it's a permanent address. You cannot change it permanently. Okay, temporarily you can change a MAC address, but permanently it is not possible because it is directly found on this hardware.
Yes. So okay. Device ID is used to identify that
NIC card which is manufactured by that company. Let's say that you have a Cisco NIC So this Cisco NIC's this card, it is identified using the device ID. Okay, and OUI is identifying that Cisco is the manufacturer of this device.
So
Okay, everyone, done? This portion done? All of you?
Yes, sir.
So we are moving on to the next section. This is your router. Now we are discussing router. This is just environment, everyone. We are having two LANs. You can see one LAN we have a laptop and a server machine. We have LAN number 2, we have PC and a laptop. And from this LAN, let's say that you are communicating to this server. Okay, so from LAN number 2, you are trying to communicate to this server. So this type of communication, it is only possible when you have a router in the middle. Okay,
Sir, I have one
let's
question, sir.
tell me.
Sir, does a router or switch have their own NIC?
Every single device which works on network, they have an NIC. Okay, they have an IC, whether it's your router, whether it's your switch, whether it's your laptop, desktop, printer, scanners, any device. Even your smartphone also, it is all working on an NIC. Without NIC, network interface card, you cannot make communication. Understood? It is
Okay.
required, mandatory.
Okay.
So this router is doing communication, okay, between all these things. So from this machine to this machine, if communication needs to happen, then it needs to be the router, which is connecting both LANs together. So main purpose of router is to perform routing, everyone, because this device directly works at network layer. Okay, and main function of network layer is to perform routing, and this is the device which basically does that. Okay, so routing means what? Routing means take information from this LAN and deliver it to other LAN. Take information from this LAN and deliver it to other LAN. So from here, it is informations are coming over here. From here, information is coming over here. This type of information exchange is going on via the router. That is why we call it a gateway device, everyone. Router also is called as a gateway. Why? Because it is this device via which from this LAN you can access this LAN. And it is this device from which you can access from this LAN to this LAN. This is just working as a gate. Just think of it like a gate. Okay. Once you enter the gate, you are accessing this LAN. If you enter like what from here, if you exit and you enter this particular side, then you are accessing LAN number 2. Just think of it like a gate sitting in between two areas. Okay, so this is what you are having, the routing. So routing table, always this routers they maintain to perform routing. Okay, to take information from this LAN and delivering it to this LAN, this is when they will perform routing. And this routing table is what is used to perform routing. Every single router maintains that, which contains this information, everyone. These are the informations like destination network information, destination subnet mask information, next hop IP address information, administrative distance, metric. All these are informations which is there in the routing table of a router, based on which router is taking information from this LAN number 2 and delivering it to LAN number 1, or from LAN number 1 and delivering it to LAN number 2. All this information exchange is going on between these two LANs with the help of these informations. Okay, so always your router performs this function. So in a very simple words, if you want to describe your router, then it is simply just a network layer device. Okay, that is your L3 device, which is used to connect multiple LANs together. Okay, multiple LANs we're connecting. So that information from here we can access from here. Okay, and informations from here we are accessing it from any other LANs. Okay, whatever LANs you are having, if you want to connect from one LAN to another LAN, always you can use router. Okay, so this is your layer 3 device, network layer. It directly works. Coming to the next device, bridge. As the name suggests, everyone, bridge. It is simply just bridging multiple LANs together. Okay, if you want to connect your LAN number 1 to LAN number 2, means you want to bridge them together. Okay, This is when exactly you are using this device. Let's say that you want to join both these LANs together, LAN 1 and LAN 2. You want to join them together. Okay, so that you can make a bigger LAN. This type of concept, it is achieved using this bridge device. It's an old device actually. Okay, these days we don't use bridges because when we are having a switch performs these functions also. Okay, so we don't need a separate bridge device to bridge multiple LANs. Always you can see that it is used to connect physical LANs, two physical LANs, to make a larger logical LAN. When you join LAN 1 to LAN number 2 with this device, the entire size of the LAN, it will be bigger. This is what we are calling larger logical LAN. Okay, and all this type of devices like bridge, always they're like what, using hardware addresses for forwarding of frames. Hardware address means same like switch. Switch also uses these hardware addresses to forward the frames. They're also maintaining table. This type of table always it helps switches, bridges in order to perform unicast forwarding of frames. Means whoever is the destination, to that machine only the frames will be delivered. No other hacker machines or any other machines will get. So whoever is sending it,
Sir,
yes.
I have a
Tell
question.
me.
What are the difference between switches and routers? Means what does a
Switch works at data link layer. Their main function is switching of frames from one port to other port. Suppose your machine is connected to this port and my machine is connected to this port, and you are sending something from this port to this port. Then switching, okay, when you send information, the information is coming to this port. The switch is switching it from here and it is delivering it to here, and my machine is getting it. Getting my point? This is switching. It is not equal to routing. Routing is delivering information from one LAN to another LAN. Getting my point? This is not about ports. This is about LANs. Two different networks we are connecting. Okay, with a router. But with a switch, we are simply delivering frames between two machines. Just all. Okay, that's it. So between same network, okay, or within the same network, when you have to deliver informations, always we are using switches for that. But when it comes to two different LANs, this is when you are using routers, because router provides you access to other LAN so that you can make the communication. Understood?
Sir, even router can do that all the work which switch is doing now?
No,
Or it has
no. Technologies wise, what we configure in a switch, right? What we configure in a switch, these things you cannot do it in a router. Okay, when you will do the configuration, okay, at the time you will understand that what you can do on a router and what you can do on a switch. Practically you will understand this. Right now, from the very broader perspective, you will think that what is the difference? Because switch is also forwarding frames, router is also forwarding frames, okay, packets. So what is the difference? But when we do the configuration, when we configure these routers, this type of switches, this is when exactly we get to know that what difference exactly these devices are having. Okay, from the layer 3 perspective, router we are configuring. From the layer 2 perspective, we are configuring switches, and there are huge differences. You will understand it in the advanced network module. Understood? Danish?
Sir, this
Yes,
advanced, this advanced network that will be included in this course, sir, or we have to do a separate course for
that is after finishing of this basic network module, you will be getting information about advanced network module from your recruiter. Okay, your recruiter will give you that information. The HR will give you that information. Okay,
sir.
because this is the basics you have to know. Otherwise, you will not be able to get the advanced concepts. Okay, so this is what you are having, everyone. Bridging is always.
Sir, in big companies, in NMCs and other companies, does router is used basically, or it has to?
These devices are most commonly used These devices are most commonly used: switches, router, then modems, then servers, okay, PCs, laptops. These machines,
So I have a doubt.
1, 2, 3, 4, 5 IP phones, okay. These devices, mostly you will find servers, routers, switches, mostly.
Okay, sir.
Hello.
Tell me,
Hello.
Mayuri.
Yeah, so the hub is also come under the like switch part.
Hub.
It does the same work as the switch does.
Yes. The only thing, the only difference between hub and the switch is that broadcast. This one is doing the broadcast.
Okay.
This one is
Okay,
doing
okay.
unicast. Unicast means 1-to-1.
Okay.
This switch maintains this table. This hub doesn't maintain this table.
Okay.
Okay. So because it doesn't maintain this type of table, that is why it is doing broadcast. And because this switch maintains this table, that is why it is doing unicast.
Okay. So the hub is only has bandwidth
Broadcast.
for a LAN, right?
If you are setting up a LAN at home, if you if for you security is not a priority, network
Okay.
security, then you can use hub device. But in every
Okay.
single company, security, data security always is given importance. Okay.
Right.
This is when exactly we don't use this device in the company. We use this device.
Okay.
Because this
So
device
we
exactly does what exactly we want. If we want to send a frame or send any information from this machine to this machine, this device exactly delivers our informations from this machine to this machine only. It doesn't go
Right.
to this machine. Okay. Always it
got it.
delivers to the correct destination, because this table always is telling the switch where exactly he has to deliver the information. Coming to the next device, everyone, this is the repeater device. We are having I guess this is the device, repeater. This is basically used for amplifying the signal, everyone. Amplification, signal modification. Okay. When we send our signal, let's say that you are sending, okay, this is your laptop, and you are sending the signal via the cable, your signal is moving. Okay. This is the standard range of cables, everyone, in network. 100 meters means when you will be sending your signal, at the time via this cable, 100 meters, up to 100 meters, it will be moving. And when it reaches the end of 100 meters, this when the signal will be going down. Okay, means it is getting lost. This particular device, repeater, it is having one input and one output. Okay, this input and output basically takes the weak signal in and amplifies it and out. Okay, just like what boosts it via the another port. Okay, this is the output port. The input takes a weak signal, and via the output, the amplified signal is being transmitted. Okay, so that it can again reach like what 100 meters, and after that again retransmission, okay, or this amplification is being done, because it is not like that from here you can reach like what entire internet without any problem, because your signal is moving via wires. Okay, via cables it is moving, and every single cable, they have a certain distance in which they can basically carry your signal. Okay, when the length of the cable is 100 meters, okay, as your signal is moving down the wire, and when it is reaching this 100 meters range, this is when your signal is getting weaker. The strength of the signal is getting weaker. And this is when we are installing this device, so that the weak signal, what we are receiving, it is getting amplified and it is again retransmitted back to that original signal. Okay. Because maybe you are having a server which is like what, let's say 200 meters from here. 200 meters. Okay. So this 200 meters, how come you can cover? This cable only connects, okay, only can take your signal up to 100 meters. So again, you are transmitting it from here via this device, and it is going in this manner to this server. Okay, this is what exactly the repeater is doing. It is basically used for doing the amplification purpose. Okay, amplification of signal. This is the whole main purpose of this device. Understood, everyone?
Yes.
Yes, sir.
Yes, sir.
Amplification. Okay, just boosting the signal. That's it. Coming to the next device, we are having repeater, everyone. Now, this is a traditional ISP internet connection, what we get at our home. Okay, when you take internet connection, this is how they are giving connection. So your ISP, internal service providers, Reliance, Vodafone, Airtel, BSNL, all these are called ISPs. They give you this line, digital subscriber line, DSL. It gets connected to a modem device. And from the modem, it is getting connected to a small device called splitter. From the splitter device, you are getting this system. You are connecting your laptop, desktop, okay, in one cable, and from another cable, you are connecting your phone. This type of phones, you are basically getting it. Okay, most of the time when you take internet connection, you get a landline phone. Okay, most of your ISPs, they provide you a landline receiver phone, okay, to make calls. Like if you are taking Reliance Jio connection, then you will be getting this landline type phones over there, they will offer you. But this type of like landline phones and our PCs, both of this type of devices, they're using the same line, DSL line, to send informations to internet and to receive informations from internet. These two devices, they don't understand the same type of language, everyone. They don't understand the same type of signal. This laptop, desktops, what we are using to communicate on internet, they understand digital signal. Okay, digital signal they understand. And these devices like phones, landline phones you are having, they don't understand digital signal. They understand analog signals. This digital signal and this analog signal both is sent via the same line. Okay, so this device is doing what? It is doing the conversion. Okay, so whatever signal is basically made for this machine, it is converting it from analog to digital. And whatever signal is like what is for this landline phone, it is converting from digital to analog. Analog to digital, digital to analog. This is what is done by this modem, which stands for modulator, demodulator. This MO stands for modulators and DEM stands for demodulators. This modulator, demodulator main function is doing two things: converting digital signal to analog so that your phones can understand it, and converting analog signals to digital so that your machine, like your laptop, desktop machine, can understand it. Okay, this is the most traditional type of internet connection what you get to see, okay, from ISPs. These days we are having Reliance Jio Fiber, Airtel Extreme Fiber. How many of you have heard about Jio Fiber and Extreme Fiber? Jio Fiber and Airtel Extreme Fiber, right? Yes. So this fiber optics. These are
fiber optics. Yes.
These are your fiber optic connections, right?
It's thin like wire.
Fiber optics.
It's fastest.
So a very small wire, very thin type of wire comes in directly to your home. It gets connected to a converter, and from the converter, we are basically connecting our machines. So this device, this type of devices, you don't get to see, like splitter device, okay, or a modem device over here, because these days, what we are getting is we get a Wi-Fi router directly from our ISP. They connect their cable, okay, their fiber optic cable to the Wi-Fi router, and from the Wi-Fi router, all these devices are getting connectivity. Okay, and these days we are not using analog phones anyways. Okay, everyone is using smartphones. So analog phones, it was there earlier, like what, 5 to 10 years back, but these days, like what, this type of analog phones are not there. So most of the type, okay, when you take an internet connection like this, you basically used to get this type of environment in which exactly modulator, domain demodulators, okay, these things are basically done by these modems. The frequency in which we are making communication, all these things are set up by the ISPs. And this conversion, okay, digital to analog to digital signal conversion, these are things which is done by this device. This is the main functionality. Okay, directly these modem devices, they are working at the layer 1, layer 2 of the OSI model. Okay, means at the physical layer also it is working, and it is working also at the data link layer as well. Okay, so this is what you are having, everyone, this particular model. Taking the screenshot. All of you taken the screenshot.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
This part taken the screenshot.
Yes, sir.
Yes, sir.
This part taken the
Yes, sir.
screenshot. This part. This part taken.
Yes, sir.
Okay.
Router 1 minute, sir. So router part sir, I not okay.
Router part, na? This is your router part.
Yes, yes.
Take it.
Thank
Now,
you.
who missed yesterday's session? Who missed yesterday's session?
Sir, I.
Sir, Jyoti.
Alok.
Alok and Jyoti. Okay. So these are the things what exactly we discussed from the very beginning of the session. Okay. So let me just tell you this. Harsha also. Just hold on.
Or even I.
Okay, those of you who want a screenshot of the first sessions, okay, first 2 sessions, simply just take the screenshot. This is what we have discussed. Take the screenshot. Taken.
Yes, sir.
Now take it. Take another screenshot. Taken.
Yes, sir.
Yes, sir.
Now take this part. Taken.
Yes.
Yes, sir.
Then take this part. Done.
Yes, sir.
Take this part. Finished? All of
Yes.
you finished?
Yes, sir.
Okay. Then after that, we discussed about this OSI. This particular part you have taken it, right, already?
Sir, but we don't have the details of all the layers.
Yes. So that part, I'm just giving it to you. Just hold on. Let me just find it. The layer notes. Let me just.
We have the ports number.
The port number. Okay. Just hold on. OSI. What is OSI model? Yes.
Oh, upar. There is the picture.
Okay. So take the screenshot. These are the functions of these layers. Taken.
Yeah.
Take this. Taken.
Yes.
Take this. Taken. Take this. This is the last layer 1 physical layer. Okay. And one thing taken, right? All of you?
Yeah.
Yes, sir.
After this TCP UDP, okay, this layer number 4 over here. Okay, so after writing this, make sure that you add these informations. This is your TCP examples. Okay, layer 4 examples, TCP and UDP. These are the differences. Okay, simply just add these informations. If you want, you can take the screenshot. This comes in layer 4. Okay, just write it in the layer 4 point. Taken?
Yeah.
Then this particular thing, all these things will be coming in layer 4. Taken?
Yes, sir.
And this particular port number. And similarly, another thing is the common TCP UDP port numbers. You can find it. Simply just go to Google. And from here, just type common TCP UDP port numbers. Okay. Just click on images. Okay, this is the port number range. The common port numbers. You can just take the screenshot of this. You have to make this table in layer 4. Okay, make a heading of common TCP UDP port numbers and just write these port numbers along with this name.
So what is RFC?
RFC stands for request for comments.
Means
Basically, these protocols are made by organizations of different engineers. Okay, different organizations, engineers, they are coming together and they are basically making these protocols and services. Okay, they are researching on it. So always these things, this type of research is being done by requesting for comments. Okay, so one engineer is commenting on something, other engineer is fixing it. That engineer is doing something and likewise someone else is fixing it. Like always, this type of protocols are being developed, are being researched like this by commenting. Okay, so these are basically RFC stands for. You don't have to remember all these things.
yeah.
These are coming from the perspective of doing research. We are not doing researching, we are managing it. For management purpose, these informations, this is what is required. These first 3 columns. Okay, you don't need the fourth one. Taken, everyone? Can I close this?
Yes, sir.
Now, those of you who are new into the session, you guys have taken everything.
Yes, sir.
So, okay, no one has missed anything, right? And today's informations also you have taken, right? This network
Yes.
devices, all the screenshots.
Yes, sir.
Yes, sir.
Okay, very good. So now some questioning and answering session should begin. We have
Yes.
6 minutes left. Yes or no?
Yes, sir.
Yes.
Sir, what will be the most short form detail of TCP and UDP?
Short form detail. Means I'm not getting you what you are asking. Short form detail means what?
Like, tell you means we are getting the full form of what does TCP does and what does UDP does. So what will be the short form of both TCP and UDP means in detail? If someone asks us, so what will we reply?
The short form of TCP and UDP.
Yeah.
This is the short form itself. TCP and UDP itself is a short form, right?
Achha.
It is not the full form. The full abbreviation is Transmission Control Protocol, right?
Achha.
And UDP is User Datagram Protocol. Okay. This TCP and UDP itself is a short form. And so right now, if you simply just say T and U, then who will understand all these things? Yeah. You cannot simply just like what if it is already short, then you cannot even make it even shorter, right? Otherwise, no one will understand it. So make sure that at least the short form you remember it, This is important, right? TCP and UDP always, this is the short form. Okay. Now, Arjun.
Yes, sir.
Yes. Which one is the biggest type of network?
WAN, sir.
WAN.
Yeah,
WAN is the biggest WAN.
because
Sure.
wide area network, no, sir.
Wide area network is the biggest.
GN.
Arjun.
Sorry, sir. Sorry, sir. GAN. Global area
Global
network.
area network. Na. Okay. Suman,
Yes, sir.
which one is the smallest one?
Sir, PAN, personal area network.
Which one is bigger than PAN but smaller than LAN?
Smaller than LAN है. Personal के बाद home area network, sir.
Which one is bigger than PAN but smaller than LAN?
Bigger than PAN, smaller than LAN.
Smaller
Sir, home
than
area
LAN.
network is home area network, sir.
Home area.
Sir, you are confusing me.
Home area
Confused हो रहे
network.
सर हम लोग.
Okay. Which one is larger than PAN?
Larger
Which
than
one? Can.
sir, metropolitan area network.
Metropolitan area network. Good. Okay. Ashwini,
Sir, it's campus area network, no, sir?
larger than can. CAN.
Okay, sir, got it.
Metropolitan, right? Ashwini.
Yes, sir.
Yes. Server sends request, right?
Yes, sir.
Very good. And client sends reply, right? Client sends reply and server sends request, right? Ashwini? No, Ashwini is silent. Ashwini is silent. Okay. Abhirami, come in.
Hello?
Abhirami.
Yes, sir. Yes,
Yes.
sir.
Server sends request and client sends reply. Correct?
No, sir. Client will request for information and server will reply with it.
Full sure? Confident?
Yes, sir.
100%.
Yes, sir. 100%.
Okay, very good. So it means I'm wrong then.
Sir, I
Abhirami?
think you are checking.
Okay, I'm just checking. Okay. Okay, next. Mayuri. Mayuri. Yes.
Absent, sir.
Okay. Who developed OSI model? Mayuri.
ISO,
ISO stands for
International Standard of Organization.
International Standard Organization. TCP/IP stands for what?
Transmission Control Protocol.
Transmission
And Internet
Control
Protocol.
Protocol. Internet Protocol.
TCP/IP.
Okay.
Yeah,
And
Internet Protocol.
UDP stands for what?
User Datagram Protocol.
User Datagram Protocol. Very good. Okay. Next, John Hanila.
Yes, sir.
Yes. What I am asking you is TCP and UDP differences.